function to the exponent. So if you've got log equals to something, what you do is you exponentiate both sides. So in other words, I'll say e to the natural log of x equals e to the 5. But what is that? That is x equals e to the 5. So, yep. There you go. Okay, I think to be fair, this is easier than example 7, right? Example 7, that quadratic substitution problem, it's a little bit sneakier, isn't it? How do I solve example 9? How do you solve that? How do you get rid of the logarithm base 3? What do you do? Well, we're going to exponentiate both sides. Instead of exponentiating both sides base e, we'll exponentiate both sides base 3. So I do 3 to the log base 3 of x equals 3 to the power 2. The 3 log 3 cancel by the definition of logarithm. So the left-hand side gives me 2x minus 6. And the right-hand side, well, what's 3 squared? Three times 3, right? Which is what? Which is 9, yeah? So, okay. And then we solve that, right? Week 1 of this course, right? So, 2x equals to 15. X equals to 15 over 2. So there you have it. That's how that goes. Well, let's look at another one. This is like number 20. Here I'm looking at log of x plus the log of x to the power 9, yowzers, equals to 20. Well, that's kind of scary looking. How do you solve this? So before this, the last two problems, we've had success if we were able to rewrite the equation as like a single log equal to something, right? Can you rewrite this so we have a single log equal to something? How about this? We can pull that 9 out, right? By property 2, so we've got log x plus 9 log x equals to 20, which gives us 10 log x equals to 20, which gives us log x equal to 2. And then what? Well, just exponentiate both sides, right? Exponentiate both sides, base e. So we have e to the log x equals e to the 2. Oh man, is the answer e to the 2 again? Wasn't that just the answer to the other one? Oh no, it's e to the 5, excuse me. Whew. There we go, diversity, that's better. So you know, diversity is our strength. We should have different answers. Different answers, that's good. So let's see here. Example 11. So, unless there's a question, you guys can jump in if you have a question. Just kind of picking my way at some of these problems, seeing how we solve them. Here, this one looks harder. Let's try this one out. I know eventually these get a little bit fussier, but we haven't quite hit the fussy ones yet. So they'll sneak up on us, I'm sure. But here's like number 22. We're facing log base 4 of x plus log base 4 of x minus 6 equals to 2. Yeah, this is what I was looking. This one's like this. This is. Yeah. This will make us think a little bit more. Okay, so here we're going to use the properties of logs. We're going to use property 1, right? Property 1 says that we've got log base 4 of x times x minus 6, right? Equals to 2. That's by property 1. First law log, blah, 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 blah. Anyway, okay, then what? The log base 4 offends us. How do we get rid of it? We exponentiate both sides, right? Both sides raised to the 4. I mean, rather base 4. So I take 4 to the log base 4 equals 4 to the 2, like so. What's that give me? Yeah, it gives me, thank you, 16. X times x minus 6 equals to 16. Now, how do I solve that? Up till now, whenever we've done this kind of step, we've found ourselves with like a linear equation, right? Which was like, oh, okay, we can solve those. Well, now we've got a quadratic equation. We can solve this, yeah? But let's do it right. So this is x squared minus 6x minus 16 equals to 0, which I think we can factor. Usually these book problems come out so they factor real nice and pretty in this part because they don't want to make you think too hard. In principle, these can come out so you have to complete the square and do the stuff we did earlier. They could be ugly, but this one's not. So to get 16, 2 and 8, which one? Minus 8 plus 2? Yep, very good. So x equals to what? X equals to 8, or x equals to minus 2. Now, here it becomes very important when you do these problems, right, that you have to go back to the original equation and check, do they work? And it's even more basic than do they work. The question is, do they even make sense, right? Like, if you try to plug, I can plug 8 back in, right? Log base 4 of 8 plus log base 4 of, 8 minus 6, that's fine. That's log base 4 of 16, which indeed is 2. So, yay, that works. But what happens when you try to plug minus 2 in? You got log base 4 of minus 2 plus log base 4 of, well, minus 8. And right here, full stop, right? Like right here, like nope, no can do, nope. See, the domain for the logarithm, positive numbers, we cannot input a negative number into a logarithm. It's not allowed, because the domain of the logarithm is the range of the exponential function, right? The range of the exponential function is positive numbers. We cannot plug this minus 2 back up in here. All right? So what that means is that this right here is extraneous. It's an extraneous solution, which just means it's not really a solution to our problem. It's a solution to the intermediate algebra problem that we came to midstream in the solution process. And so that's just something we got to watch out for any of these problems, like number 23 or 24. They're kind of the same kind of thing. Probably 25 is similar. 26 is another one of these. I've asked you guys a bunch of these. But listen, I'll save those for next time. The other thing I'll talk about next time is the Richter scale. There's like some problems about decibel ratings in the Richter scale. I should talk about that. That's kind of the application of logarithms that I've selected for us, because that's an interesting problem. But anyway, that's it for today, guys.